Okay, thank goodness. Great. Hi there, my name is Nicholas Seed, and I'm with the CEO of Undesert Corporation, and we are transforming wastewater into purified, usable water. And this picture just shows we can take really any sort of wastewater from, relatively clean water that comes out of the ocean or, processed water through sanitation systems, all the way down to produced water, the dirtiest water in the world. And I'll tell you exactly how we do that in the course of this presentation. Feel free to put questions in the chat, or we'll definitely circle back. Also, since this really is desalination at its heart, we can, well, I'd like to close this presentation by having a giveaway of a $10,000 giveaway. And so you've got to stick around until we get to that in order to see what I'm talking about. So anyway, without further ado, the initial market that Undesert is focused on is the oil and gas industry. And why? Because in just Texas and New Mexico, which is the Permian Basin, operators there spend $5 billion every year to pump this wastewater underground. And this is a huge waste of money. It's a huge waste of water. In Texas, it causes earthquakes. Texas experienced the #2 earthquakes outside of California entirely because of this wastewater disposal system. Of course, it contaminates underground water as well, and that's really not a sustainable solution. So the reason they have so much of this water is that for every barrel of oil that comes out of the ground during their oil exploration and drilling process, 4 to 8 barrels of produced water come along with it. And this water is full of drilling chemicals and underground salty water. It's really very, very nasty stuff, which is why the state of the art is to pump it back underground and just get rid of it. But of course, we have a better way. Undesert can purify produced water for around $1 per barrel. That is less than half of the cost that industry currently spends to transport that water and then either pump it underground, or in New Mexico, they chemically treat it and store it above ground. And here you can see a picture of our device. We call it SWAP, for salt water purification. Each SWAP can process 500 barrels of this produced water and turn pretty much the whole lot into distilled water, perfectly pure water that's suitable for agriculture, it's suitable for beneficial reuse, which means that the projected ROI is very, very fast for all of these oil, these wastewater disposal companies and the producers themselves. And we validated this with Shell Corporation. We participated in their Game Changer product accelerator with water management folks like Martin Water, who actually spend a whole bunch of money doing this disposal or evaporation in above ground ponds, as well as with local governments in New Mexico and Texas, who are very concerned about their own water issues. In fact, Governor Grisham in New Mexico just announced a $500 million clean water pre-purchase, which is the same trick that they used in COVID land to develop the COVID vaccines. They did a vaccine pre-purchase in order to find the tech companies. And so we're in talks with all of those people.
The swap technology is very flexible. We can deal with almost any kind of wastewater, water that contains hydrocarbons, salts, and other contaminants. We have the option to start with the steam stripper, where we take the hydrocarbons out and actually use those hydrocarbons as fuel to strip the incoming water of its hydrocarbons. That gives us a water and salt solution, and the swap process takes over at that point. And our technology is basically thermal desalination. And we've made major innovations on that, which we'll explain shortly. But basically, our technology can purify the water, recovering over 80% of the incoming water, and we can actually render it to dry salts if that's desired for the customer. We've been evaluated by 2 national labs who are modeling our technology for us. The table in the lower left shows basically we can remove over 98% of the incoming contaminants in the water, hydrocarbons and salts. This table shows Undesert on the left. Our maximum feed is much above the other technologies. We have low environmental impact. Reverse osmosis, which is the third column on from the left, is limited to only 50,000 parts total salt. So that means they can't even address the Permian Basin produced water that we're talking about. And of course, they have a huge waste stream as well. The graphic on the right shows basically seawater at about 25 or 30,000 parts. Reverse osmosis can handle 2 times the concentration of salt in seawater, but the produced water that we're dealing with in Texas and New Mexico is 4 times the concentration of salt in seawater. Our technology can handle up to 8 times the seawater concentration. This graphic shows a comparison to the current 95% of the water in Texas and New Mexico is now pumped underground with great environmental and earthquake risk. But this is, by comparison, Undesert's energy costs are lower. There's no seismic or fresh water risk. We can actually, since our technology is modular, locate it right at the well or a cluster of wells, eliminating the transportation costs. And on the far right, with the bare land that's around all wells and all pipelines, we can actually grow forests. We've shown that already, and get the customers CO2 credits. The environmental benefits of the SWAT process, basically we recover 80% of the feed water, and our product water is extremely pure. A later slide will address that. We also offer the option of 0 liquid discharge. Particularly in desert countries, we can render the salt readily to dry salt for either reuse for minerals or disposal. Our technology does thermal desalination below the boiling point of water, which means that we can recycle up to 80% of the energy that we put in, and our process is energy agnostic. We can take in renewable energy, solar or geothermal. We can use waste energy, engine exhaust, waste steam, and of course we can use primary energy. And they're designed for continuous operation, little to no downtime, automatic operation, and low maintenance. David, I see your hand. We'll get to your question shortly.
That's right. And so that's really this technology, desalination, has a whole bunch of applications, from drinking water all the way down to oil and gas. So we're focusing now on these 3 verticals. One is energy companies, agriculture, and then government applications. The initial one, obviously, oil and gas, we're talking about right now. But in energy, the growth of the hydrogen industry is actually presupposed on there being an adequate supply of perfectly pure water. And that's something that our product water meets that criteria, no problem. In terms of agriculture, I mentioned New Mexico has this $500 million clean water pre-purchase. It's smack in the middle. All of the water that we displace and use for agriculture means that the water that they're currently drawing for agriculture can be used for higher purposes like human consumption. And so that in that regard, we're solving a lot of these water issues in New Mexico. Governments themselves, of course, local governments, but all across America, there are lots and lots of these water issues. All of these like Superfund sites, they have huge evaporation ponds that we could take care of. Certainly expanding internationally, which is actually on the next slide. There's a lot of opportunity globally because oil is not a it's a global issue. So the U.S. is right up there, but in Saudi Arabia and Canada, there's a lot of drilling and wastewater that needs to be disposed of. And that's really how do we find focus is always the challenging part for a platform technology. But if we focus on oil and gas distillation, I think there's a lot of dollars on the table.
This slide looks at the history of our technology. We started off doing research at the Federal Research Facility in Alamogordo, New Mexico, and basically wound up with patents issued on 2,300-year-old technology for the class upgrading the class innovations on the classic solar still. We have now moved it to the point where we have industrial scale units, and basically our product water, as far as reuse of treated water, our product water is generally better quality than most rainwater. So we can take seawater, saline water, produced water, and yield usable water, and we're at a TRL of 7 to 9.
And one of the things that I forgot to mention is that another application is removal of PFAS, which is a very potent chemical that is in our wastewater, but not in our distilled water. That is the output of our system.
Our first commercial installation was outside of Dubai in the UAE. The site started off as a calcic horizon, which is basically a desert parking lot. Nothing would grow there. Applying the desalination technology, in a year and a half, that was converted to a blooming oasis. And now, 5 years into the operation, they're growing 10 kilograms of organic food per square meter per month year round. That's about 10 times soil agricultural yield.
And we have a lot of really great partners who have helped us on our journey. The NMSBA operates the Sandia National Lab and the Los Alamos National Lab, and we've done a software simulation of our technology in order to validate its scalability parameters in preparation to go into manufacturing. I mentioned we're part of the Shell Game Changer Product Development Accelerator, and we learned a lot about the workings of the oil and gas industry there. We found Shell through the Mass Challenge Accelerator in Houston, which we participated in. And as well, we participated in the Techstars Industries of the Future Accelerator. We're in the top 10% of the X Prize carbon removal project, as well as we got some great partners in Texas and New Mexico, Produced Water Research Consortium. In terms of our financial ask, we're looking to raise a pre-seed of $2 million as a safe note at a $7 million cap in order to kickstart our manufacturing. We've partnered with a manufacturing firm in Texas, and they know how we can mass produce those shipping containers that you saw on a previous slide. We're a Delaware C in good standing and with a very fast path to profitability, which you can see here from our financials, that essentially once we've manufactured that device, and you can think of that as about like in the 100,000 type ballpark, then it's very fast, just a couple of months as a return on investment for anybody who deploys that device. On this slide, I'll do a quick introduction to the team. My name's Nicholas Seat. I'm the co-founder, the CEO of Undesert. I initially built a technology company called Auditude, which I built from 0 to 50 people before I sold it to Adobe Corporation in 2011. I did a double major, engineering and economics at Harvey Mudd College, and an MBA at UCLA.
My background, I'm Hill Kemp, CTO. My background is chemical engineering. I got over 40 years in the chemical, petrochemical, and refining business. Started with the research on all solar desalination uh, around 2010, and have since evolved that into a technology which is now we're calling SWAP, and we can compete with RO on a cost and a performance basis, and produce at industrial levels up to the thousands of barrel per day quantity needed by the oil industry and by municipalities.
That's right. And during my MBA, I actually competed in and won the Rice University Business Plan competition for my first startup, Auditude. And one of the judges of that competition was May Aquari, who's pictured here on the right. And I've been seeing May over the years as I came back to the competition as a judge and alumni. And this year, I went back to the Rice competition with my daughter Anya, and she and I met with May after the competition, and May said, "I am between gigs, and I love the idea of Undesert. So would it be possible for me to join the team?" And I said, "Wonderful, that would be just the best." And so we were able to twist May's arm and bring her on as our COO. And we look forward to a great relationship as things progress. We're also joined by a great bunch of advisors from academia and industry. Most recently, Morris Clark, the former VP Treasurer at Marathon Oil, joined our advisory board, which has been a great source of information in the oil and gas industry. And that's really the vision. We want to take a waste product, in this case, produced water, and turn it into a valuable asset. And for instance, we could forest around these oil pipelines because trees only need sunshine, CO2, and water to not just grow, but thrive in the desert. And that means that around these oil pipelines, you could be growing pine trees and carbon offsets. We could do that around the world, and 1% of global desert forestry would actually offset all of humankind's CO2 emissions. 2% would undo all of the damage to the atmosphere since the Industrial Revolution, turning the clock back on climate change. This technology could actually save the planet. And that's the presentation. So thank you very much. I would now like to move to question and answer mode. I see a lot of good questions in the chat. And while Rachel is looking at those for us, I wanted to end with this special offer. This ChatGTP was nice enough to generate this for me. It's something I would never be able to figure out how to do it myself, but look at that. That is a ChatGTP interpretation of what our technology looks like. Excellent. What we want to do in this presentation is give 10 people a $10,000 discount on our evaluation of their water, and which is actually the first stage in the process of deploying our technology. We have to know what's in your water. Is it, PFAS? Is it, concentrations of oil and gas residue? We've got to know that. So we do this chemical assessment like we did for which Hill showed you we did earlier, and then we'll provide that report to you, and then we'll decide what kind of a device would be appropriate, and then would run the same water through our device, and then perform another chemical analysis, and then present those results back to you. So anyway, that's the special offer for listening to this presentation. And
Thank you.
Yep, go ahead.
Nick, thank you so much. At the moment, I can see that David Lopez Guzman has a question. He was raising his hand, so I opened the chat for anyone who would like to ask any questions to jot their question here. If not, you can reach out to both Nick, May, and to Hill. Do you want to? Do you have a slide with your details and contact information?
Yep, this
So-
info it goes directly to me because we're a small company. So yeah, info ad would work just fine.
Great. So this is Nick's contact details for any further questions. If you have any, you can of course write them here or reach out to Nick or to Tech Showcase. I'll
Yep.
leave the link to our website right here. Just a moment. And either way, we really appreciate it. If you have anything to add, then feel free now or just a second.
All right. Otherwise, I can start. Art has a question. What happens to the impurities? What if the impurities are something I want to recover or we want to recover? And Hill, can you answer that question?
Yes, yes. Our technology removes over 80% of the water, and depending on some optional final steps to our process, we can either render the salts and remaining impurities as a heavy brine. The drilling industry uses what they call 10.5 brine, which is 10.5 pounds per gallon. So we can produce usable brine for the oil field drilling step, or we can reduce it to a dry salt. And basically, if you're interested in recovering the impurities, we do nothing to the incoming salt. We simply separate it from the water. So whatever's in the incoming feed water, we can deliver that as dry salts for either recycling or storage or sequestering.
An interesting idea is to take all of those dry salts and turn them into building or construction material, because the salt is so concentrated, it dries overnight in the desert air, and every day a 1 millimeter layer gets added to that salt. After a year, it can be cut into bricks and sequestering that salt permanently above ground. So in fact, if we were to be able to create some structure out of it, you could build houses, you could build whatever you like out of those salt bricks, and that would be a great way to sequester that salt forever.
Yep. And yep. One interesting sidelight here, a Houston VC had their construction contractor sign an NDA with us to look at the details of our separation technology. And this guy has built and operated several different kinds of water purification technology. When he looked at it, he said, "Why in the hell hasn't someone else already done this?" So we're very pleased and very confident in our in the path forward, and we hope to have our industrial module built and operating soon.
Right. And as part of that, I think I'm going to jump to Charles's question. I'll get back to Ankush's question. But Charles asks, are there valuable materials in the salt that could be recovered? And, I'd suggested using it as construction material, but of course you could mine it for valuable substances. And that's something that in this dry salt form, it's much more amenable to being mined for any particular material you're looking for. For instance, in the oil and gas industry, they could actually recover their expensive drilling fluids back and then recycle those. Or if you're looking for, more lithium for the battery industry, you could certainly do that. I think the anecdote there is that there is so much salty but lithium heavy water at the Salton Sea in California that our technology could directly apply to and help clean up that pond. And Kush says, have you published anything? Can you share these papers? What we have is not, published in a journal or anything, but we have a white paper and documents that we'd be delighted to share with you. And if you do want to receive those, the simplest way is to email me directly and at that info @ and then I will follow up by email. But certainly, we don't give out proprietary information, obviously, but we'd be happy to answer any questions that we can. Okay, so let's see.
Art is asking about a cost comparison with RO or nanofiltration. Of course, nanofiltration does not, it removes solids, but not salts, Art. So nanofiltration is not really desalination per se. And in comparison to RO, we outperform them on a life cycle basis on the cost. And also, RO generally has anywhere from 20 to 40% waste brine. That is not a part of our process. We process all of the incoming salts either to usable, saleable brine or dry salt. Yeah, there's the cost comparison to RO. Their costs are higher, their energy demand is higher. And of course, the fact that we can use both renewable energy and waste energy means that our energy costs are very, very low and inflation proof. The solar power does not go up with inflation, so to speak.
That's right. So one interesting anecdote is that the desert city of Neom, actually, and that's in Saudi Arabia, they actually reached out to us to ask us, can we clean up their reverse osmosis brine, which they currently dump back into the ocean. They take their very concentrated salt, this 20% waste stream, and they can't do anything with it because it's too salty to do anything with. So we can take reverse osmosis brine, run it through our system, and then create fresh water and dry salt. So even more concentrated brine. Yeah,
we've actually processed several different sources of reverse osmosis brine to pure water and either heavy brine or dry salt.
That's right. And foresting deserts in Saudi Arabia is one of their objectives as well as a part of their NEOM project. So we can help with that.
And Charles, you asked the question about it's definitely scalable. We can go up into the thousands of barrels a day. And the processed water, I mentioned this just in passing earlier, but our processed water is generally higher quality than most rainwater. And I realize that's a heck of a claim, but we've got the analysis to prove it. Rainwater in most U.S. locations runs in the single digit parts per million hydrocarbons. Our water runs in the single digit parts per billion hydrocarbons. So the quality is as good or better than our water for reuse quality is as good or better than rainwater.
In terms of where are we actually have a working prototype at the pilot scale, but the next level up is the shipping container. And that is the piece that we haven't done yet. And of course, what we're looking for financing from, either customer financing or equity financing. And so that's something that we've got the design, we know how to do it. We've partnered with the correct manufacturing firm, and so it's the hard part. The rocket science is done, the patents are issued and filed, and we just have to do it. It's so the risk is the technology risk is pretty low. Okay, let's see. do you want to talk flow rates, Hill? Do you have a? I
Flow
think
rates on.
why don't we use this metric for our production device? What does 500 barrels of water per day mean? What's a barrel anyway?
An oil barrel is 42 US gallons. And so 500 barrels would be somewhere in the range of about 20,000 gallons per day of distilled water coming out of the unit.
That's right. And so it needs to be at that scale because these oil and gas folks are in this, several tens of thousands per day. No question.
And we can the container you see in that picture there, we can cluster those either by stacking them up or putting them side by side and get our capacity up into the thousands of barrels a day that they need.
That's right. There's a different question in the let's see. Oh, I see. They've already answered.
I've put in short answers, but feel free to expand if you feel.
Okay, in the QA, Hill, do you want to take a quick look at the answered category?
Oh, wait, what's that? I'm not sure which one you're talking about.
So Randy asks, can you use recovered heat from industrial processes to run your process?
Oh, yes, absolutely. We can use recovered heat from industrial processes. Basically, we can use any source of heat from 140 degrees Fahrenheit and upward.
Right. And that is to say low grade waste heat, which is plentifully available in industry. We don't
waste
need
steam. We can even use engine exhaust, by the way, as a heat source for this process.
Right. What's key to understand is we're not boiling the water like a lot of maybe competitors might do. We're evaporating the water, and that means we're heating the water to 70, 80 degrees below the boiling point of water, and that doesn't require nearly as much energy.
Yeah, you just cited a centigrade temperature, 70 or 80 degrees C. Yeah. And Charles, your question, why wouldn't the Saudis not fund this? We actually have a firm proposal before them. As we understand it, their government panel is now evaluating our proposal. And I don't know whether the war over there is complicating things or not, but they're taking longer than they thought they would require to approve. But we have a firm proposal to plant 10,000 trees in the Saudi desert just off the Red Sea, feeding reverse osmosis brine.
Randy asks, recovered heat from my industrial process is appropriate to run this process. And
yes, absolutely. Waste steam, for instance, or waste heat of any source, engine exhaust, boiler feed water, boiler blowdown, for instance, is an excellent source of energy for us from industry.
Right. And so I had a few bonus slides to run through, which I have here while you're thinking of more questions. If there's no more questions on the table, which I don't see. So this slide is really about that New Mexico's clean water pre-purchase. And so they basically are asking us or people of the world to find a solution to clean up this huge amount of brackish and produced water, which New Mexico has tons of. It's the second largest oil producing region in the US. And certainly 75 million gallons of oil per day is, four times that per produced water per day. It's a huge amount. There's very little fresh water on the planet. And if you think of like, what do you get in snowfall and rivers, it's dwarfed completely by the gorilla in the room, which is the ocean. Of course, as Al Gore likes to say, we live on a blue planet because of all this water, and that makes us very unique in the solar system, in probably the entire universe. We have tons of water. We just really need to balance out where that water is located and how it's being used. And distillation technology is the key to doing that. There are 4 billion people experiencing water scarcity every single month. So that's it's a human tragedy, which again it's to do with this water imbalance that we face as a species. Got to fix it. 24 billion gallons of clean water could be brought back in the New Mexico ecosystem every day.
Nick, there is a question on the swap model. How many of them, how big is the swap model? Do you want to go back to the slide that shows it? I'm sorry, you were just about to finish the last.
Yeah, no, I'm pretty much done. So this
how big is the swap model? How many of it have you manufactured so far from Orline Morel?
Right, so this model only exists in prototype, which is to say we don't have a full shipping container full. Our current status is we've got about a capacity to run about 5 barrels per day, and we need to 100x that. And the only way we're going to do that is with a correct mass production facility. Right now, our device, we shouldn't be scaling it at this kind of device. We need a professionally manufactured scale and scalable device. So that's why we've partnered with an excellent product development firm in Texas who can help us get there.
Charles, your question about New Mexico and Texas and the reuse of water. Texas actually has a major program to purify the produced water and put it into a mostly depleted river there. So we're trying to get more information about that. We don't have all of the details yet, but Texas is as right now it seems to be open and in fact encouraging, the legislature is encouraging the Railroad Commission to come up with ways to recycle the water. And we're working with a midstream company to do exactly that.
And Hill, there's another question for you from Randy Cole at the bottom, who would be interested in finding out more about the economics of using excess heat from the Fischer-Tropsch process to productize water from the FT process, assuming 1 million BPA H2O.
Wait,
It's
okay.
possibly something you can send in writing.
Yeah, Randy, you and I need to talk about that specifically. I think I understand your question, but I'm not completely clear on it. I'll send you my email address.
Perfect. And then, you know, certainly we're happy to
I'll be happy to get into more details with that with you.
Absolutely. Yeah, yeah.
Nick, I'm sorry to interrupt. Would you be able to leave your contact details here in the chat for everyone to see?
Yeah, sure.
Again,
like I said, info goes to me, but at the same time, I could leave my personal email address if I can find the chat button.
I see Hill left it.
Everyone, that's it.
We really appreciate all the good questions. Thank you very much. This is a very critical issue for the industry, but also for us as a society. We feel like we're addressing a major problem for everybody.
Hill, can you answer this this solar power? Jess asked how much solar power is being used to sustain water production, including solar-driven electrochemical desalination.
Where'd you see that?
In the chat.
It's
Oh,
in the chat, not
okay,
the
so-
Q&A.
Oh, sorry, okay. Uh,
And so it's really my understanding that solar-driven desalination is it's largely powering reverse osmosis. And I mean, that's great, except reverse osmosis as a technology, it's not good enough. 20% of reverse osmosis processing is waste, which is extremely salty water, which is currently it's either stored above ground in desalination in evaporation ponds or dumped back into the ocean. And so even though it's sustainably powered, it's not sustainable as a water desalination technology because of the waste stream.
yeah, and in seawater desalination, that waste stream can go up to 30 to 40%. So reverse osmosis is not a sustainable answer to the water problems.
Right. Okay, well, if there's no further questions, and you've got my contact info. I think I have all of your contact info. So really appreciate you all listening, and thank you, Deep Tech Showcase, Rachel and team for setting up this this venue for us. I'd love to stay in touch. You can see our website at undesert.com. We have a bulletin that goes out. You can subscribe to that. And but otherwise, thank you all for coming, and have a great and well-hydrated future.
And feel free to reach out on LinkedIn as well.
Correct.
Thank you so
We're all
much.
there.
If you want to leave the links for your LinkedIn account, for LinkedIn and for your website on the chat for everyone.
I'm easy to find, so is Nick and Hill. There are not many duplicates.
We can also send it out. We're gonna send out an email with
Yeah, if you want to send it out in the
Yeah.
email to follow up, that would be great. Thank you so
Yeah,
much. I don't have it
exactly.
handy right now.
Very
Thank
cool.
you so much. It was an honor.
Thank you.
Thank you, Rachel and David.
Thanks, Nick. Thank you, Hel.
Bye.
Bye, guys.
Take care.
Bye. Thank you so much for